Hi everyone, today we're going to talk about glacial, erosional, and depositional terms. Okay. The first thing we'll talk about is erosion. I color coded this so the things that relate to erosion I put in red. But glaciers are the most powerful geologic agent. So you can see here, this is a time-lapse image showing, large, we're talking about lots and lots of mass, right? And as it goes, you can see in this image here how it's actually ripping and pulling away parts of this mountain. This view is from underneath. They dug underneath this glacier. And again, it's this time-lapse, but you can see how the glacier is flowing here. And as it goes, it's um, eroding the surface of the mountain that it's on. One of the things that you'll see or a sign from a glacier is abrasion. So you get these striations along a surface, and it's helpful for geologists because they can then determine which way the glacier was flowing. So you can see in this picture here, it's basically scratch marks because as the glacier went, it pulled rocks and boulders and stuff with it, which then made a polish or striations onto whatever surface it was going over the top of. Another characteristic we see erosion-wise is glaciers produce U-shaped valleys. So you can see in this animation here, a glacier forms because of all of its mass and weight. It erodes away and creates this telltale U-shaped valley, okay, which is different than what you would see from a valley produced by a river, which would be more of a V shape. Okay, but because the glacier has the large amount of mass, it tends to create this U-shaped valley. So that would be a true sign that that valley was either formed or modified in some way by a glacier. All right, so now we moved on to yellow color for how glaciers move things. Okay, so not just eroding, but moving things. So I've got an animation here showing really two concepts. So the first one is sediments from the valley floor is going to get carried along from the base. So you can see when the drill comes here, this ice along the bottom is moving a little bit slower, right? But it's going to move the sediment along. Anything that's dropped on the top, like this flag, for example, is going to get carried along the top. Okay, so glaciers act as moving agents, kind of like a conveyor belt. That's a good way to think about it. So the flow is constantly moving downhill. So the glacier is always moving downhill. And it's going to carry with it anything that is on top of it. So here's a picture of sediment that's on top of this glacier. So wind blown or stuff that's fallen off the top of this mountain back here. In that video earlier, we saw again that the material below the glacier getting pulled away. Here's another interesting picture, this big boulder on top of Mendenhall Glacier in Alaska. So most of your large boulders you see sitting around here are what we call erratics. So they were dropped there by a glacier, just like this. So the boulder falls on top of the glacier, moves down the direction of the glacial flow, and you get yourself these, like here for example these. Okay, so how would these big giant boulders, you can see how big they are compared to these people, how would they get up here on the side of this ridge? And it was from a glacier. Okay, and you can even see if you look real closely, there's some striations here from the glacier going over the top, and this is in Yosemite. All right, and then lastly, I went green here for deposition. So what do glaciers do when they drop this material that they've been carrying? Well, it's what we call glacial drift. Glacial drift is any deposit that gets made from glacial activity. And we've got a lot of it here in Illinois because we are at kind of a leading edge of a glacier. One of the types that we'll talk about is glacial till or till deposits. There's really two types of glacial drift, and the first one's till. And what it is, it's anything that's deposited directly by the glacier itself. Okay, so it's going to be unsorted, meaning that it's not going to be layered or having heavy stuff down at the bottom. It's just basically like this animation is showing you here, is as this glacier is melting away, so this is retreating. Okay, so the ice is still flowing forward, but it's just the leading edge is melting. And as it melts, it's going to drop whatever it has at that front edge. So here's a picture. This is in England, and we've got a lot of this stuff here actually, is till. Okay, so that's your, you can see it's just a mix of soil and dirt and rocks and boulders. And that was stuff that was just dropped by the glacier as that leading edge of the glacier melted away. I took this picture, this is out by Fox Valley Mall, but it had snowed, and you can see the snowplows made this huge big pile of snow, and when they plowed, they brought a lot of dirt and stuff with it. But you can see as this snow is melting, it's leaving behind, look at all this sediment and dirt that gets dumped on the ground that was being carried by that ice. It's the same concept for till being dropped. All right, so there's a couple different types of till deposits we'll look at. One of them is a moraine. Okay, so a moraine is the deposit that's made by that leading edge at the end of the glacier. Okay, so it's not the general till, you would say, would be all this stuff that's being deposited along the way. But when a glacier is stalled or it stops at one location for a while, it's like a conveyor belt, right? It brings all this material up to the front and it's going to make a long hill of debris. And then eventually when that glacier recedes because of a warming climate or decrease in snowfall, it's going to leave that hill behind. So this diagram is showing it here. So here's your glacier in place, bringing the material forward, and then it leaves this hill behind after the glacier is gone. So here's an actual photo. This is an end moraine. Okay, so this glacier here is retreating, right? So maybe the climate's a little bit warmer, maybe there's less snowfall up there, whatever it is, and it's left behind. This is where the glacier end used to be, and it was a conveyor belt dropping all that material, so it leaves a nice hill. It's called a moraine. The other one is called a drumlin. A drumlin is a hill that's been reshaped into elongated hills. So you have to imagine it this way, that you've got this till or this material, and as the glacier was flowing, basically what it did is it smeared this hill out. Okay, so you can see it here. You had a hill, and then the glacier came along and smears it out. And it tells you, basically it's pointing you the direction that the glacier was flowing. So this glacier was moving in this picture to the right. Here's an actual drumlin. In this case, you can see here that the glacier in this case was moving to our left. Gives you an idea of the scale. Look at the farm here. So pretty small compared to the size of this thing. Okay, so that was all till. So that was stuff that was being unsorted, just dropped directly by the ice itself. The other kind we have here is stratified drift. So it's stuff that's sorted by streams or running water. So for stratified drift, you see we've got these layers, right? We've got these layers sometimes, and a lot of times, the heavier material down at the bottom, and then you get these layers because it was, again, stuff that was being dropped down by water. Okay, so the first type of stratified one that we'll talk about is called a kame. Okay, so a kame is done when there's a glacier and there's a hole on the top of the ice or a lake, or in this case, this is called a moulin, is where you've got water that basically has found a place that it's going to melt its way down through. So it's a hole in the top of the glacier. And it's going to carry sediment down with it. And when the glacier melts away then, that sediment is left behind in the form of a hill. We've got a lot of these around Wheaton, okay? Blackwell Forest Preserve, Johnson's Mound, which is out by Canelan High School, as an example of a kame. Here's a picture of one. So we had a glacier over the top of this, and all the sediment was getting dropped down, and then the glacier melted away and left behind this hill. Very similar to that is what we call an esker. It's a ridge of stratified drift, and it's caused from tunnels being run underneath the surface of the glacier. So if we have this glacier here, okay, and you can imagine water running along the surface, or it goes down to the bottom, and then it creates a river underneath the glacier, and that river deposits material. So this video is showing actually up on the surface of a glacier, so imagine the same thing underneath the glacier with the sediment being deposited, and after the glacier melts away, it leaves this long perpendicular or parallel to the flow of the glacier, just put it that way. So this would be an example. Here's an esker. Okay, so if we're looking, you can imagine the glacier was coming at us, and this was a river that was underneath that glacier. So it's kind of this snaky, long thing that goes off into the distance. So there's a river that was running underneath the glacier, and it deposited all this material. And then the glacier melted away and left behind the esker. All right, and the last one here is called a Kettle Lake. Okay, a Kettle Lake is another stratified one where you have the retreating glacier leaves behind a big block of ice that depresses and pushes down into the earth, sediment-wise, okay? And then when that block of ice melts, it's left a depression, which then fills up with water to form a lake, okay? So Herrick Lake in Wheaton here is an example of one. So if you've been over there, and Herrick Lake is actually the only naturally formed lake in DuPage County, but it was formed by a glacier. So a big block of glacial ice broke off, depressed the ground, and then a lake is formed there. All right. So now let's look how this all kind of goes together. So I've got a couple pictures here. Up in the upper left, this is 14,000 years ago, and we had Lake Chicago here. So you have to imagine we had this glacier coming down here, and as it melted, it created lots of water, and the same thing was happening over here with Lake Erie and whatnot. But anyway, when these glaciers on the picture on the right here, the white region here is showing these moraines. Okay, so at some point the glacier stalled right here, okay, and it deposited a big hill of debris, and then it melted away, and then it advanced, and so you can see we have lots of moraines in northern Illinois here, and that's because these glaciers went through periods of advance and retreat, and then we have the Valparaiso moraine system right here. And this one right here was the one that actually, this used to be Lake Chicago. So where Chicago currently is was a lake. Okay, and it was held in place by this Valparaiso moraine system. Okay, so Wheaton, which is the star here, we are on top of this moraine. So when you drive around this region, like as you drive to Glen Ellen, okay, or Lombard, you go down a big hill, and what you're actually doing is you're going down the side of this moraine. So you've probably done this lots of times without even knowing it. And as you move towards Aurora, towards Fox River, it's the same thing. You'll get a decline or a drop, and that's because you're going down the side of the moraine. Okay, and that's this right here. Okay, so there's the Valparaiso moraine, and we're right on top of it. And you can see here where, when eventually the Lake Chicago got so big, it was able to break through right here. Okay, so Lake Chicago was able to break through the moraine in what is now, that's the Des Plaines River. Okay, and then Illinois' rivers down here. Now looking at rivers then, which is the last thing we'll talk about here, is how glaciation affected these rivers in Illinois. So the ancient Mississippi River about 2 million years ago wasn't where it currently is. Okay, so this is the ancient Mississippi River, kind of came through the middle of the state here by Peoria and down this direction. And the Mississippi ended up getting pushed west, and the Illinois River turned south, and large volumes of water. So you have to imagine, as we had this big glacier, as it melted, that was a lot of fresh water, which when it melted had to go somewhere. Okay, so what it did is this large amounts of water created these large river valleys, and actually shifted the Mississippi River to its new position. Okay, because you had sediment being dropped here by these moraines, and that changed the direction of the ancient Mississippi River. Okay, so as a result, what we end up with is a lot of these river valleys are really wide, much more wide than what the current rivers are, the capacity of rivers going through there. And the reason is because it used to be a lot more water coming down that way, and it created these big wide valleys. And then since then it's decreased, but that's the current position of the Mississippi and how it was altered. And a lot of these other rivers too, the Illinois River, Des Plaines River, Fox River, Rock River, all got changed because of glaciers. Okay, if you have any questions, remember to shoot me an email or stop me in class.